no idea what I just played. I just made that up. Sounded okay? All right, so I'm not going to make this up. So what we're going to look at is vector calculation. So I'm moving on into part 3 of this. And what we're going to be doing on part 3 is doing some more vector calculations. First thing I'm going to talk about a little bit is the magnitude of a vector and what we mean by that. All right, so basically the magnitude of a vector represented by u is just the length of the vector. And we usually represent it by this, the double bar u, although I noticed our textbook does this. They just do that, kind of like looks like an absolute value. I really don't prefer it that way, so I use the double bar when I do that. So if you have a vector in component form, ai plus bj, then the magnitude is the square root of a squared plus b squared. Okay, well, let me show you where that comes from. Okay, it's actually pretty simple. So what we're going to do is just kind of put a dot somewhere up here. It doesn't matter where too much. And what we're going to do is draw a basic vector here, you know, in component form. So we're drawing from the origin like that. All right, well, the vector that I'm drawing is u equals ai plus b times j. And what we're going to do is just go straight down to the x-axis. And if you think about this, this is going over a. So a is kind of like this piece of the right triangle. So that's a. And then this part right here is how high up you are, so that's b. So ai just means over a, and then bj means up b like that. Okay, and then you always have some sort of an angle theta there. Well, what we're going to do is we're going to call this thing right here just something like a distance or something. This is what the magnitude of vector u is, so we use that symbolism like that. Well, we have the Pythagorean theorem that we know about, so we just do a squared plus b squared is c squared. So we're going to take square the hypotenuse, that's equal to a squared plus b squared. So again, this is Pythagorean theorem. And then you square root both sides. So what you end up getting is the magnitude of the vector u is square root of a squared plus b squared. So it's nothing new. What it is just, it's the Pythagorean theorem. You're finding the length of the hypotenuse of a right triangle. So that's the idea. Okay, so let's go down the bottom of the page here, and we'll just crunch out a couple of these. So first of all, with this one, let's crunch out this, sketch this vector. So 3i plus 4j, you would go over 3 and up 1, 2, 3, 4. So that would be the vector, and you want to draw that from the origin. Okay, like that. So that's your vector, all right? And again, just like in the last diagram, what we end up having is we end up having a right triangle. This side's 3 and that side's 4. So the magnitude is that side right there, okay? So again, what we do on this is you can just do the Pythagorean theorem. So you really just end up doing the formula a squared plus b squared, which comes from the Pythagorean theorem. So what you're going to do is the square root of 3 squared plus 4 squared. So that's the square root of 9 plus 16. So that's the square root of 25. So therefore, we would end up with the magnitude of u being equal to 5. And you're familiar with that already. That's the 3, 4, 5 right triangle. So that would be the magnitude. Okay, this one, remember when you see this symbolism, that's another way to write the component form of a vector. So this is the same as negative 4i plus 6j, right? So let's go ahead and plot this. So if you plot the vector, you go to the left 4, and then you would go up 6, and then sketch in the vector, and then we'll do the magnitude and represent the magnitude on here. Okay, so that would be my vector. Now that's sketched. So this time what we're going to do is just say, okay, the magnitude of this vector, I'll call it vector u, is the square root of the first term, the a term, negative 4 squared, and then plus 6 squared like that. So that ends up giving you the square root of 16 plus 36. All right, so that will end up giving you the square root of, and that is, let's see, 36, 46, that's 52, like that. All right, now what we can do on this is we can break this up. So this divides by 4, so you can break that up into 4 times 13. You're looking for a square root factor of 42. Perfect squares are numbers like 4 and 9 and 16 and so forth. So that square root of 4 would be 2, so you get 2 root 13. Okay, so what we get as the result is the magnitude of that vector u is 2 times square root of 13. And yeah, you do need to know how to break up radicals when that shows up. All right, so that's how you find the magnitude. Again, that's nothing more than the length of that vector. Okay, it's like the hypotenuse of a right triangle. In this case, that would go straight down, and then that would be your right triangle where you'd have a side, -4, you'd have 6, and Pythagorean Theorem will give you that answer. Okay, all right, let's go to the next page. Let's try just these two. Pause the video and then come back and check and see if you're doing these okay. Okay, so go ahead and check and see if you're on the right track here. Number 1, you should have got 10. Number 2, you should have got square root of 13, which is already simplified. As far as drawing the vector, on this one I went left 6, up 8. On the second vector I went over 2 and then down 3. So you want to know how to plot the vector and everything. You don't really have to draw the triangle because you're just doing the formula magnitude of u is a squared plus b squared, so you can go directly there. If you did a right triangle on this, what would happen is you would have this side right here would be really 6. You don't have to use a -6, and then this side right here would really be 8. So you can just go use the Pythagorean theorem to find that. And then this one, and again, you always draw your triangle up to the x-axis. You don't want to draw it this way. So on this one, this side would really be 2. And that side, instead of having -3, I'm just going to put 3, because sides of a triangle are always positive numbers. Okay, so that's how you do that. Hopefully we did that okay. All right, so we're going to move on to the next thing is the unit vector. And there's a lot of times when we need to create a unit vector for a variety of different reasons. And so a unit vector is a vector that has a magnitude of 1. So the length of the vector would be 1. Therefore, that's why we call it a unit vector. So if you have a vector in component form, ai plus bj, or using the brackets, then the formula for a unit vector is just the vector divided by its magnitude. So you divide the original vector by its magnitude. So what I'm going to do is I'm going to prove to you that that when we get a unit vector for this, that'll have a magnitude of 1. Okay, so let's write this down now. So let's say that we have a vector v, which is ai plus b times j. Okay, well, we know that the magnitude of this vector v is the square root of a squared plus b squared. Okay, like that. So what we would do if we do the unit vector, we just use the letter u for usually, and then what we do is we would go through and do ai, divide it by its magnitude, and then plus bj, and then divide that by its magnitude, like that. Okay? All right, so what I'm going to do on this is I'm going to show you that if we did the magnitude of this unit vector, we would get 1. Okay, so here's how this goes. We're going to do the magnitude of this unit vector. Okay, so watch carefully how I do this then. So what I'm going to do is I do the square root of this squared, what I highlighted, so that would be a over the square root of a squared plus b squared, squared plus, and then it would be this whole thing, the b over that, so that would be b over square root of a squared plus b squared squared. Okay, like that then. All right. So, well, here's what we basically have then. Okay, if you squared this out, you would have a to the second. When you square a radical, when you anytime you take a square root and square it, the radical comes off. So you just get a squared plus b squared there. Okay, so this is going to be a squared plus b squared. Okay, when you do this second part, you're going to have b to the second. And again, when you square that radical, it comes off and gives you a squared plus b squared. Okay, like that. Okay, well, I've already got two fractions with the same denominator. So if I put this together, I keep the denominator, I combine the numerator, and look what happens. Okay, what is the value of a squared plus b squared divided by itself? Yeah, it's 1. So square root of 1 is 1. So I told you, okay? So the idea is that formula is always going to work, and it's going to give you a magnitude of 1. So that kind of proves that that formula gives you a unit vector, okay? Basic algebra, okay? All right, let's go to the next page, and then we're going to do unit vector on this. Okay, so let's go ahead and let's sketch this vector. So we're 4i over 4 up 4j. So that's what that original vector u would look like, is like that. Now the unit vector is going to be in the same direction, but its magnitude is only going to be 1. So it's going to, that unit vector is going to be just a vector that's 1 unit long. So basically, here's what we do. When we do this, we want to do the magnitude of vector u. So we do that by doing the square root of 4 squared plus 4 squared, like we've been doing. So that would be the square root of 16 plus 16. And that would be the square root of 32. And this is a good example of something that you want to break up. And, you know, there's a couple of things. 4 is a perfect square. 4 times 8 is 32. 9 does not go into 32. But 16 does. 16 times 2 is the best choice. So what we're going to do is break this up into the square root of 16 times the square root of 2. Square root of 16 is 4. So we get 4 times the square root of 2. Now that's the magnitude of this vector right here. That's how long that vector is. So the unit vector, what we do is we just simply take this vector, 4i plus 4j, and we divide it by this magnitude. So that magnitude is 4 root 2, like that. Now that's going to give a unit vector, but we do have to clean this up. So one thing I want you to notice is, of course, the 4's cross out. So I'd end up getting 1 over square root of 2i plus 1 over square root of 2j. And then you can rationalize that denominator, and I'll just review that real quick. We've done that a lot this semester. So multiply by root 2 over 2, and you're going to get square root of 2 over 2. Okay, so the best way to write our unit vector then is square root of 2 over 2i plus square root of 2 over 2j. That would be the unit vector. You could find the magnitude of that and prove that it's 1. I'm not going to necessarily require you to do that, but it's really a good thing to learn how to do, is verify that that has a value of 1. Now what happens on this one is it would end up, this unit vector would just be, you know, this little thing there. It would go in the same direction, but the magnitude of the unit vector is equal to 1. Okay, so that's how that gets put together. Okay, that's how you do a unit vector. Find the magnitude and take the vector and divide it by the magnitude. Okay, all right, so the next one we have negative 3i plus 4j. So we go to the left 3, up 4, and just get a sketch of the vector. Okay, I always like to kind of sketch vectors so you can see what's going on in the problem and what the meaning of the problem is. Okay, so here's what we do. First thing we're going to do is we're going to do the magnitude of this vector. I'll call it vector v. It doesn't matter what you call it. So we do the square root of negative 3 squared plus 4 squared. So that would be the square root of 9 plus 16. Now you got to put that together. So that would be 25. So the square root of 25 is 5. So the magnitude of this vector is 5. Okay, and this is something that you really kind of hopefully you already recognize on this. This would really be a triangle with 3 and 4. That's a 3, 4, 5 right triangle. So that magnitude is the length of that hypotenuse. All right, so now what we do is we do this. I'm going to write this as negative 3i plus 4j, and then I just divide by that magnitude, and you would get an answer, okay? So the unit vector would be this, or you could write it, if you want to just write it in this form, you could say negative 3/5, comma, 4/5. Okay, that is a unit vector in the same direction. So actually that vector would be just kind of, it'd be in the same direction, but it would be only 1 unit long, okay? Now, just for fun, I'm going to check the answer. I'm going to do this a couple of times on these problems, but just to show you. If you wanted to check your answer, what you would do is you would do the magnitude of the unit vector you just did. This is a good exercise for students to do. You take the first term and square it, and then we take the second term and we square that, and then this should turn out to be 1, so let's just verify that. Okay, this would be 9/25 when you square 3/5. 4/5 times itself would give you 16/25. So don't panic when you see all these fractions. Fractions are your friend. 9 plus 16 is square root of 25. That's square root of 1, so it's 1. So I told you, it's a unit vector. Okay, now you believe me. Okay, very good. Okay, all right, so let's go ahead and let's move down. You can pause if you need to look over what I've done there. And let's just kind of recreate what I just did. I want you to sketch these two vectors and find the unit vector. Okay? Okay, so check and see if you got these right. So you're kind of out of room on the graph on the first one, so you should have just went over 5 and up 12. That's how you would sketch that vector. When you find the magnitude, you do the square root of 5 squared plus 12 squared. So that would be 25 and 144. Ultimately, you do the square root of 169, so you get 13. And then what you're doing is just dividing each part of the original vector. You have 5 and 12. They get divided by the magnitude, so that would be your answer. Okay? Now, just, for something, I'm going to do this one more time and show you that it's generally relatively easy to tell you're right. So if you do the magnitude of this unit vector, we would expect that to be 1. So what happens is we'd go square root of 5/13 squared plus 12/13 squared. So that would end up being the square root of 25 over 169 plus 144 over 169. So that ends up being the square root of 169 over 169, which is the square root of 1, and that's equal to 1. Okay, I did that kind of fast, but that's the idea of how you would check your answer. They're all verifiable. Okay, the second one, you should have went left 3, down 1 to draw your vector. The magnitude would be the square root of negative 3 squared plus negative 1 squared. So you'd have 9 plus 1 or 10. Okay, then what I did is I just took each part and divided by that magnitude. Negative 3 over root 10, negative 1 over root 10. Then I rationalized that denominator. Okay, so that would be the answer to those two problems. That's how you find the unit vector. All right, so let's move to the next thing here. All right, next thing I want to talk about is the direction angle of a vector. And when we talk about a vector having a direction, well, it formulates some angle in standard position. So I'm going to show you how to do that. So the direction angle, we just basically, when we find that direction angle, we use trig values. And the direction angle, generally, we like it to be written as a positive angle between 0 and 360. You could also give it a negative value too. But what I'm going to do on these problems is just kind of standard give a positive angle. Okay, so let me show you what happens on this. Let's just kind of randomly put a dot out here. And let's draw a generic vector. Okay, like that. Okay, so this is my vector. My vector v is ai plus bj. Well, of course, what we do is we get a triangle. Every time you draw a vector in standard position, you end up getting a right triangle. So what you'd have is this whole side right here would be A. This whole side right here would be B. And then this would end up just being like the magnitude on this. All right, so what we would end up doing on this is you would know the magnitude. So this would actually just be the magnitude of v like that. Okay. So what you do, if you look at this diagram right here, well, the tangent, and you would have an angle theta would always be the angle from the positive x-axis to wherever you are around the circle. In this diagram, the tangent, remember, is opposite over adjacent. So what would that be? That would be opposite B over adjacent A. So that's B over A. Okay. And the sine would be, that one is opposite over hypotenuse. So that one would end up just being the side opposite B divided by the hypotenuse, which is the magnitude of V. Okay. And then finally, the cosine is the opposite over adjacent. No, teacher. Sometimes I get to talking, can't talk and think at the same time. This one is adjacent over hypotenuse. So side adjacent would be A, and then the hypotenuse would be the magnitude of that vector. So you get these trig ratios, and what you can do is easily find the direction angle by doing that, just by applying some basic trigonometry. So it's kind of up to you. Most of the time I just use the tangent, okay, when I'm doing a magnitude. I find that just to be about as easy as anything, but you can use any of those things that you want to. Okay, so let's go ahead and do the direction angle on these things. You'll need your calculator to do some of these too. So this one, we're going to plot the vector. We did this same one before, over 5, go up 12. So let's just go 9, 10, 11, 12. And do it like that. So up over 5, up 12, and then sketch in that vector. Okay, like that. All right. Now what we end up getting is we get a triangle on this. So I'm going to draw a triangle. You actually don't have to do that on these problems. It's not a bad idea because it helps you to understand what's going on in the problem. So our job is to find this angle from the positive x-axis to the vector. So we're going to do that. So that means basically this side right here would be 5, and this side right here would end up being the 12. So I'm going to use the tangent. So I'm going to do tangent of theta. And remember, if you look above, what I did is I said do the tangent's B over A in this diagram. So what you would do here is B would be 12, A would be 5. So we do that. And then we got to go to the calculator, so we're going to do the inverse tangent of 12 over 5, and we're going to write this direction angle in terms of degrees, okay? All right, so let's do that. First thing you'd want to do is make sure your calculator is in degree mode, so press your mode button. Make sure you move that over to degree mode, okay, like that, and you can quit to get a clear screen. And then we're going to go second tangent to open up the inverse tangent. Then we do 12/5. And the benefit of graphing is you'll kind of see if you're on the right track. You can kind of see if this makes sense to you. Makes perfectly good sense to me. That looks like it's in the 60s somewhere. So anyway, the direction angle would be approximately, we'll just say 67.4 degrees. Okay, so you're using basic trigonometry to find the direction angle of your vector, okay? All right, the next one goes like this. So we just have, if you compute this one, you would go left 3 and then down 1. And then we'll connect the vector like this. So basically what I'm going to end up doing on this, and you kind of end up having to do a little bit of a calculation on this thing too. So what we're going to end up doing is I'm just going to do the tangent on this. That's usually what I do, is the tangent. So the tangent of this angle theta, and that angle theta is really going to be the reference angle there. So we have to do a little calculation on this. So we're going to do B over A, -1 over -3, or we end up getting the tangent of theta equals 1/3. That isn't going to give us the direction angle. We have to do a calculation to get there then. So you have to kind of pay attention to how we get this then. So what I'm going to do is I'm going to do theta is inverse tangent of 1/3. Okay, and that will give enough information to figure this out. So I go inverse tangent of 1 over 3. And that'll give me an angle of about 18.4 degrees. Okay, well, so here's what the deal is on this problem, is if you extended this vector, in the opposite direction like this, if you just extended it like there, that 18.4 is actually that angle right there that's between the x-axis and that. So we want to get the entire angle, see. So what we have to do is you would take the 18.4, then you would go another 180 degrees, okay? Or you can think of these angles are equal, so it would just be 180 plus that angle there. So then your direction angle is just going to be 180 degrees plus 18.4 degrees. So that direction angle is going to be 100, and that would be 198.4 degrees. Now, if you're a little bit unsure of yourself when you're doing this, well, let me show you how easy it is to check until you're right. So if I was to go and take the tangent of this angle, look what happens. 198.4. If I do that, I get, oops, I put the wrong thing in there. Okay, let me try that again. Tangent of 198.4. I just want to show you what happens and see if this makes sense to you. Okay, I get this. Well, that's about a third. Okay, so the idea is it's not hard at all to check and tell that you've got that direction angle correctly, because remember in this problem, the tangent of theta was equal to 1/3. And 0.33 repeating threes is what 1/3 is anyway, see. Okay, so that's how you do a directional angle. You're going to see me always just using a tangent, but when you sketch that out, you may have to do a calculation. Okay, all right, so let's do this, and this will wrap up this part of the video. So I want you to do this, and then I'll end the video. Okay, so check yourself out and see how you did here. Okay, so check the first one that you sketched it right. You're going left 4, down 5. So that does mean you're in quadrant 3. All right, and then the direction angle is all the way from the positive x-axis to there. So it's a quadrant 3 angle. So again, what you do is you do the tangent of the j component over the I component. Form that ratio, you get 5/4. Okay, and I'll show you a couple of things on the calculator on here. So when I did the inverse tangent of 5/4, I got 51.34. But that's a quadrant 1 angle. See, what really happens on this is the calculator is giving you this angle here as 51.34. Well, you still got to go another 180. A straight line has a degree measure of 180. So that's why you do 180 plus 51.34. Okay, now a quick way to check is just to do this. If you take the tangent of 231.34, that should be close to what 5/4 is. Okay, so if I do 5/4, I get 1.25. So we rounded, that's why it's a little bit different. So you can always check your answer and do that. Okay, the next one, real simple. You just go to the right 5 up, 5 for your vector. This would be your direction angle there. This one, you formulate the ratio 5/5. Tangent 1, if you do the inverse tangent of 1, you will get 45. So this one's in quadrant 1. So there's very little doubt about what that angle is if you're in quadrant 1. All right, so that's how you find a direction angle. So I'm going to close off this part of the video. And then I'll do the next part of the video will be algebra of vectors. Okay, good luck. Woohoo!